Okay, YouTube, this is my last bit of my module on solving systems of nonlinear equations, in which we're going to look at an application, basically, of these types of systems, and specifically one that involves a geometric model. And so let's go ahead and take a look at what we have here. Essentially, it says that many geometric problems can be modeled and solved by the use of systems of nonlinear equations. And of course, I'm going to provide us with a little step-by-step strategy here. But essentially, how we can use systems here. One thing that I want to mention, and you'll see a lot of rectangular problems here, but is this. Essentially, we could, if you're looking at this problem here, come up with the values of these two unknowns as long as we could come up with two equations. And that's a pretty common thing there. As long as we can come up with two equations with the same two unknowns, then we could usually solve for these unknowns. And so the two equations we're going to be coming up with essentially are one equation with respect to area, which is just going to be length times width here, and then the other one is going to be an equation that has to deal with the length of fence that we have here, but we can come up with another equation that involves x and y. And so for step number one here, it says that we want to use variables to represent unknown quantities. Let's go ahead and read through this problem here and talk about the values of x and y, and then defining what they represent, and then going forth and writing equations to help us solve them for the values of x and y. So we say that we have 36 yards of fencing here. To build the enclosure that we see over here in figure 8.13, it says some of this fencing is to be used to build an internal divider. And so we can see this internal divider here. It says if we'd like to enclose 54 square yards, what are the dimensions of the enclosure? Well, there are two measurements that they gave us here. One was, one was length, and then the other one was square yards. And so what I want to point out here is that when they give us this length this way, we're going to write an equation for length, and when they give us square yards like this, we're going to write an equation for area. I suppose we need to start with defining our variables though. So let's go ahead and move forward with that. We say it's a number of something, and in terms of number of, since we're looking at x and y, I suppose these, it says what are the dimensions of the enclosure. These are the things we're trying to find. And so we say the number of yards, and I'm inclined to call x, since it's the longer one, I'm inclined to call it length. So the number of yards of length is our x variable here. So this is going to be the number of YDS of width. And so with these, let's go ahead and look at our length equation. Now, in terms of total amount of length here, if we were to look at a downward view of our rectangular region here, I mean, they've given us a nice little picture here, but if we look down upon it, then we could say that x and x represent these kind of side lengths that run all the way through the pen here. But as we look at these middle quantities here, these middle lengths, these were all y's. And so when we talk about the total length of fence here, our expression that we could write basically, I would think, is that we get x plus y plus y plus y. In other words, we get 2 x's plus 3 y's, and what our restriction is that we have 36 yards of length to do this. So this would be like our, I want to say our length equation here, not in terms of, I guess the rectangular length, but I would say the total length of fence. And then we would say that our area equation, while we're at it here, what do we know about the area of a rectangle? Well, we know it's the length times the width here. And so we're going to say that x times y, just because I want to keep it alphabetical here, we have 54 square yards for this. And so to solve a system like this, we have two equations and two unknowns. Because one of these is a product and the other one's a sum, what I'm going to suggest is that we just use the substitution method then. And because I want to get one of these equations, variables by themselves, I'm going to choose one that's easy to solve for. How about we just choose to say solve for, I don't know, y in the second equation, or x or y, because these have non-1 coefficients up here. So how about I'm going to choose, let's do this. We say xy equals 54. Let's divide both sides by x. Why not? We'll get y by itself here. So if we divide by x, the x's cancel out, and what we get is this y equals 54 over x. And so essentially now we know what y is. I'm typically calling this with the substitution method our modified equation here. That's going to help us solve for y later on, but it also is going to help us to plug this back into our first equation here for our y variable and rewrite it all in terms of x's. So if we have 2x plus 3y is 36, and now we know the value of y in terms of x. It is 54 over x. We get 54 over x. What we're going to do is go ahead and simplify this here. Looks like 3 over 1 times 54 over x. Well, 3 times 50 is 150, and 3 times 4 is 12. So 100, and this is a plus 162 over x equals 36. So one algebraic method that we want to remember to use here would be this. Essentially, we're going to multiply the entire equation, the entire EQ, by the least common denominator to eliminate fractions. So to eliminate fractions, essentially fractions. Fractions. So looking at this, we'd say, well, the least common denominator between 2x over 1, 162 over x, and 36 over 1 would just be x. And so if we take everything times an x, what happens essentially is you're going to see that on the left side here we get 2x times x, which is 2x squared. We get 162 over x times x over 1, which x's cancel out, we just get 162. On the right side, we would have to take this times an x also, but we get 36x. Something that at least we see as quadratic, so we can set it equal to 0 and try to factor it. And so that's what I'm going to try to do here. I'm going to subtract 36x from both sides just so that we can get this equal to 0 again. So we see that 2x squared minus 36x plus 162, okay, would be equal to 0. And because everything's divisible by 2, let's go ahead and rip everything in half. If we divide everything by 2 here, divide by 2, I'm going to borrow some more space on the right here. But we would see that we get, I suppose, just x squared minus 18x's. Half of 162 is 81. 81 here. And this one, oh, I like this one because I can see that two things that multiply out to be 81 that add up to be a negative 18, they would both have to be a 9 and they would both have to be negative. And so the interesting thing here is that we get either x minus 9 equals 0 or we get x minus 9 equals 0. In both possible instances, we get that x is equal to 9. And so for our solution, we could say solution, we're going to get 1 here. We'd say both of them had an x value of 9, so we'll say, well, just really one solution. And if x is equal to 9, then what's our y value? Remember our modified equation right here. If we were to see, well, say that 54 over x, this was really our y value, then really we get 54 over our x value, which is 9, and 9 goes into 54 6 times. And so with respect to this problem here, I'm going to put a big fat cloud around this here. Let's go ahead and do that. But we want to interpret our results. And so we could say that if x is the number of yards of length and y is the number of yards of width, then our last task here was to answer this question here and check it in the proposed original wording, check the proposed solutions in the original wording in the problem. But basically what we could say is that there must have been, or must be, 9 yards in length and 6 yards in width. And you could see that if we were to take 9 times 6, we would certainly get 54 square yards in here. And if we were to have 9 plus 9, it'd be 18. And 6 plus 6 and 6 is 18, and 18 plus 18 is 36. We certainly do get the 36 yards of fencing here. So what I want you to try now is the similar situation. Go ahead and draw your own rectangular space, but it says find the length and width of a rectangle whose perimeter is 20 feet and whose area is 21 square feet. Write an expression for area and perimeter, substituting in what you know, and then go solve for the values of x and y and interpret those in the original context of the problem.